Okay guys, let's take a look at our lesson for today. This is day 1 of Taylor series. Yes, we are going to spend 4 days on Taylor series. It's going to be fantastic. This is day 1. You probably recognize this first part right here of this definition, if you will, formula. So this is for Taylor series centered at x equals c. And this first part probably looks quite familiar to you. It's the beginnings of Taylor polynomial. We spent a couple of days on Taylor polynomials and we know how to create those now. The additional piece that we have here is, first of all, this part is called the general term. So that's the general term. And then in some cases they'll write the summation part with the sigma notation. What we will be required to do on the AP test is they're going to want us to write the first 4 terms. So we can write the first 4 terms, the first 4 non-zero terms, okay, just to be clear. The first 4 non-zero terms. And then we would write plus dot dot dot, and then you could write the summation, this part right here. You can skip, for the AP test, you can skip writing this general term separately. Notice that the general term is just this that exists in the summation. Now, sometimes they will just ask for the general term, like in this example we're getting ready to do, which means you don't have to write the summation. So I'm just going over the technicalities first before we jump into what we're going to be doing. So here's our formula, regular. It's like creating a Taylor polynomial. We are going to need to write a general term, whether we show it as a general term, like this, for this particular problem, we could just stop, right here, we'd be done. Or whether we want to include the summation, whether they ask for the summation or a sigma notation. And again, just like with the polynomials, the names, Taylor series and Maclaurin series. The Maclaurin series are centered at 0. Okay, as far as what you need to memorize, these 3 right here, you have to know cold. You have to memorize them. These are going to be on formula quizzes. I'm just going to tell you so you're prepared. I am not going to put the 10 tests that we learned in the last unit on a formula quiz. I won't do that. Not that they're not important, it's just I'm not going to put those 10 tests on there. I'm letting you know up front. But I am going to put these series on there. Now, some books use K's and some books use N's to write the series. It doesn't really matter to me. I just want you to be used to both. I prefer the N's. Why? I really don't know. I don't know. Maybe they're prettier. I don't know. It doesn't matter. You could write the series with an N or a K. All right. Interval of convergence. Note on these 3 Maclaurin series that you're going to need to know is basically all real numbers from negative infinity to infinity. What we're going to learn on this day 1 is in basically using these particular 3 series in reference to those 3, we are going to learn how to make one from scratch. So this one we're just going to do like we did the Taylor polynomials. We're just going to make it from scratch. We're also going to learn how to use our memory work right here to make our lives a little bit easier, to create them instead of from scratch by using these as a basis, as our foundation. So those are the 2 things that we're going to look at today. So let's look at the first one. We're going to create this one from scratch. If we are told to find a Taylor series for that particular function, we are pretty familiar. Now, note though, it's not talking here, just a little nuance in terminology. If you remember with the Taylor polynomials, it was asking us to do like, the 5th one. It was talking about like the 5th power, or to the 5th power. They're not doing that here. They're saying the first 4 non-zero terms. If you'll notice, for example, for sine, for this one, the first four non-zero terms actually go up to the 7th power. And we've created this before. And so we should know or remember what happens to this, x to the 6 and the x to the 4 and the x squared. What happened to those? Yeah, exactly. The derivative there was 0, so it wiped them out. So just keep that in mind. It actually wants 4 terms. However far up you need to go to get the 4 terms, that's what you're going to need to do. So let's just keep that in mind. All right, so let's take a look at this one. We are going to start with the function. We're going to center this at 2. So we have, the function given, f of x equals e to the 5x. So I'm going to go ahead and find f of 2 because that's where we're centered. So I would substitute a 2 in there and I would get e to the 10th. So then that's going to create a term. That's great. We're going to need a first derivative for sure. So I take the derivative of that and I get 5e to the 5x. Then I find f prime of 2, and that is 5e to the 10th. Okay, the second derivative, I'm going to get 25e to the 5x. Then I find the second derivative value at 2, and that's going to give me 25e to the 10th. I'll need one more. The third derivative is 125e to the 5x. And the value, the third derivative value at 2 is 125e to the 10th. So we're creating this from scratch, this series from scratch. We need, we set it up very much like we did the Taylor polynomials. We set it up the same way. So let's write it. You do not have to write this part. You don't have to worry about that. We're going to start with our first term is e to the 10th plus, using our format just like we did previously, we'll have 5e to the 10th times x minus 2 plus, then our next term is going to be 25e to the 10th times x minus 2 squared over 2 factorial. You do not have to simplify, you can just leave it like that. Plus, let's see how many terms. We have 3 terms so far. We need another one. 125 e to the 10th times x minus 2 cubed over 3 factorial plus dot dot dot. Now after that we write the general term just like this format shows us up here. Plus dot 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 plus. Alright, so let's come up with the general term. It's kind of like when we were working with sequences, we tried to figure out what pattern it was so that we could write the pattern. That's kind of what we're doing here. We're writing the pattern. And looking at all those terms, we can see that e to the 10th is in all of them. So we just kind of look at it piece by piece. Looks like we go from 1 to 5 to 25 to 125. So looks like probably, multiples of 5, right? 5 to the n. Now notice that the series that we're going to be memorizing start at 0. That's kind of typical. A lot of them do start at 0. When you're writing your general term, you need to kind of think about that. Where would you want to start it? The general term itself, notice the general term itself does not say where the n starts. So if you choose to start yours at a 1, your general term would look different than mine if I started mine at 0. So it is possible for general terms to look different but still be correct, and that's okay. I'm going to think about starting at 0 because I think that's easier for me, because as I look across here, if I did 5 to the n, 5 to the first, if that was 5 to the 0, that's 1. So I'm going to think about starting at 0. So my general term would have like 5 to the n. Well, let's draw this part. Oh no, we're just doing the general term. We won't do that part yet. Okay, so the general term would be, and I would put it right here, would be like 5 to the n. That would take care of this piece. They all have an e to the 10, so we'll go ahead and put that there. X minus 2, how am I going to be able to recreate that to the n, right? That would work. X minus 2 to the n. And then over n factorial. Okay, that would be our general term. Now, if they wanted us to write the summation, if they wanted us to tell them where we started in, we certainly could. We could, this is what they've done up here with this formula. They've written their formula out, they wrote their general term, and then they said plus dot dot dot, and they wrote the summation so that would show where they started. And so we can do that, and I'll just go ahead and put that on there. It doesn't ask us to, it just says the general term. We could actually stop, but if we wanted to, we would just say plus dot dot dot, and ours is starting at n equals 0, and it's just that same general term. Okay, and you certainly can create them from scratch. Yes. Yes. 0 factorial is 1. I know that's a crazy, crazy thing. There's a beautiful proof and logic out there on why. You could Google it and it would tell you why. Seems strange, but it is. Okay? Alright. So you can create these from scratch. Our issue with creating them from scratch is how long did that take? It took just a little while, right? It took several minutes. What if I had already memorized e to the x and did something else with it? What if I had already, and let's just look at e to the x. Let's look at it. I would have to make some adjustments. And that's what we're going to learn how to do on the next page. We're going to learn how to make adjustments. Okay? So let's do that. There's 5 different techniques that we will explore on manipulating the series that we will have memorized. So we will know the 3 special series. There are other series. If you look in your textbook, you'll see like a list of different series that are very useful. We are going to focus on those, the 3 that I showed you, because they are important and because also the AP test focuses on those 3 as well. So we're going to focus on those. We're going to look at 5 different ways to adjust. Now, today we're going to do numbers 1, 2, and 3. We're going to look at these 3 techniques. As we go on in this concept of Taylor series, we will bring in 4 and 5, but today we're just going to look at 1, 2, and 3. Okay, so let's take a look at our first one. And also we have a sine here, we have cosine, and e to the x. So we're going to look at each one of them. So let's look what's going on right here. We are asked to find the first 4 non-zero terms and the general term. If we wanted to, we could do this from scratch. We don't have to use this technique. What would finding the derivative of this be like? We'd have to chain it, wouldn't we? And as they got larger and larger, it just would be a bigger and bigger mess. And then we would have to put in, a 1 and a 2 and a 3. It's just going to be a little messy. But we could do it. What we're going to do, though, is we're going to use the sine as our basis, and we're going to practice technique number 1, which is substitute. We're going to substitute into the series. This is technique number 1. So the first thing I'm going to do is I'm going to write the series up there for sine. Just going to copy it down. I went ahead and wrote the general term just so it would be up there. So the way the substitution technique works is we actually substitute. In our series, for every x that's there, we're going to substitute an x squared in its place. We're going to substitute. So let's do that. So this is going to be the series for sine x squared. So the first term, instead of being an x, it's going to be an x squared. And the second term, instead of an x cubed, it's going to be an x to the 6th. Then we will have x to the 10th. And then we will have x to the 14th. They want the general term, so let's go ahead and rewrite the general term for this newly created series. We still alternate in the same way. We have x squared to the 2n plus 1 instead of the x, and you can write it like that, or you can write it in a different way. You can distribute the 2. I mean, whichever. It's fine to just leave it like that. And there's our new series, which is a little bit quicker, probably more than a little bit quicker than doing that one from scratch. Okay? We okay? Let's look at the next one. On the next one, we are asked to find a Maclaurin series. Now, all these are Maclaurin, and those are the 3 series that we are memorizing. It's the Maclaurin series with the zeros. They're centered at 0. We're asked to find the first 4 non-zero terms and the general term. Now, let's look at what we're being asked to find. We're asked to find x cosine x. So with this one, we're actually going to practice technique number 2. We're going to practice multiplying or dividing the series by a constant and or variable. So this one, we're going to practice technique number 2. And so I'm going to write the cosine series up here first. Okay, there's the cosine series. Now, while I have those up there next to each other, look at those 2 series next to each other, the sine series and the cosine series. I'm hoping that you notice some similarities and differences that will help you in memorizing those. What helps me is remembering that cosine is an even function. That's what helps me remember that it's the even powers. Certainly, whatever helps you remember which powers they are, that's what I'd go with. But that's what helps me. And that sine is an odd function, and it has the odd powers. Alright, so now let's multiply this whole thing by x. So what we're going to generate is x cosine x. So the first term is going to be x. And then the second term, going to be x cubed over 2 factorial, and then we just keep going, x to the 5th over 4 factorial, x to the 7th over 6 factorial plus, and our general term, I wrote it like this. I wrote it as the 2n plus 1. That just gave me an extra x, multiplying by x. That's the way that I wrote it. It's certainly not necessary to write it exactly like that. I'm sure you come up with different ways to write that. As far as work to show, you do not have to show, the original. If you want to, you can. You don't have to. If that's in your head and you don't need to write it down, you can. Actually, I am real visual. I have to write it down so that I can work with it, but you don't have to. You could go straight to the answer. All right. The last one is actually the most complex. We're going to use techniques 1, 2, and 3. All 3. I know, it's a crazy one. 1, 2, and 3. We have to do it in layers. Now, again, if you wanted to do this from scratch, you could. But finding the derivative of that, 3 or 4 times, I don't know. I don't know. It was going to take a little while, and then plugging in and finding the values. I think I want to do this other thing. So I'm going to teach you how to do that. I do need some room just so that y'all in the back can see. I don't want to be writing down low. So is everybody done with this? Okay. So we're going to be using the series for e to the x. So that's the first thing I'm going to do. I'm just going to go ahead and write it down. You probably noticed, and I'm not writing the general term here because there's so many steps, it's really just not beneficial to write the general term every time, so I'm just going to leave that off. This is scratch work for us anyway. It's not like that's our final answer. You probably noticed that I wrote more than 4 terms. That's just because I know some of those terms are going to disappear. And you don't have to know that up front. Let's say if you don't know that and you're working with it, you can just go back and add more terms. Or maybe you recognize the pattern and just can go ahead and add the term. So it's not a problem. We have created this one right here. Now we have memorized it. That's our basic one. Now we're going to do this one. What technique do you think this one is going to need? Substitution, technique number 1. So everywhere there's an x, I'm going to replace it with a negative x. So let's do that. And let's copy that down. Why is that third term still plus x squared over 2 factorial? That's exactly right, because we had to square it. We had to square the negative x, so it caused it to be positive. So that one is keeping its positive sign. Alright, so we've layered on e to the negative x. We have that one down now. Now we're going to go to technique number 3. Technique number 3 says that we are allowed to add or subtract 2 series. This is wanting us to add the 2 series together. So we just, physically add them together. I'll show it like this, e to the x plus e to the negative x. And then we're just going to add them together. So 1 plus 1 gives us 2. What happens to the x to the first terms? They're canceled, they're gone. So then I have 2x squareds over 2 factorial. And my x to the third terms are gone, they're canceled. And then I have 2x to the fourth over 4 factorial. And my x to the fifth terms are gone. Do I have enough terms? No, I need 4. I always need 4. You can't ever put less than 4. That's what the standard is, 4. So I could go back and add them up here, but let's look at this pattern. Can we figure out what the next term would be? We could, right? It's not a real difficult pattern. The next term, it looks like to me, would be 2x to the 6th over 6 factorial. Does that seem okay? And if you wanted to double check yourself, you could certainly go back and add those terms in and figure it out. Okay? And then plus ... All right. One more to go. I almost have what they've asked me to. I'm just missing that divide by 2, right? So we're looking at technique number 2, multiply or divide the series by a constant and or a variable. So I'm going to, you can think about dividing by 2 or multiplying by a half. I'm just going to think about multiplying by a half. So the final piece, the final series, the e to the x plus b to the negative x over 2 is going to be 1 plus x squared over 2 factorial plus x to the 4th over 4 factorial plus x to the 6th over 6 factorial plus dot 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 plus. Now we're going to have to come up with a general term for this. Ideas? Well, we have an x in the numerator. How can we generate the 0, 2, 4, 6? Okay, x to the 2n. What about the denominator? Very good, very good. And that gives us our general term. Okay. We doing okay? We've practiced the first 3 techniques.